The Princess and the Pea is a fairy tale where the royal identity of a young lady is established by testing her mechanical sensitivity. The accounts differ slightly, but at least one pea is placed under at least 20 mattresses, on which the lady spends the night. The next morning, she complains about having slept horribly due to feeling something hard in the bed. In the story, this is accepted as sufficient proof that she is a true princess. The questions then become: is it possible for normal humans to feel a pea under 20 mattresses? And if not, what is the smallest possible seed dispersal structure that can be felt under 20 mattresses? To answer these questions, we are going to use a simple model that consists of two components, based on a 1981 paper by Phillips and Johnson. 1. A model to convert the displacement of the pea to a force exerted on the bottom of the mattresses. 2. A model to convert the force at the bottom of the mattresses to a displacement at the top of the mattresses. The simple force model assumes that any strain profile can be decomposed into equivalent line load deflections, whose force profiles can be calculated. The total force profile is then simply the summation of all line load force profiles. The model used for determining the displacement felt on top of the mattresses will be the stress-strain equations under plane stress conditions. Phillips and Johnson used this approach with rubber material and found that the maximum compressive strain response most closely matched experimental results. There is a wide range of mattress dimensions, but the standard thickness is usually around 200 mm. Multiplied by our 20 mattresses, the total height of the mattress tower would be 4 meters. Whole green peas have an average diameter of 8 mm. They would make up our spherical deflection at the bottom. With some assumptions, our simple model suggests that an ideal displacement of 0.16 mm can be found at the top of the mattresses, which is unfortunately undetectable to humans. Phillips and Johnson found that the fingertips of their most sensitive test subjects had mechanoreceptors 0.60 mm beneath the skin, which we can use as a theoretical lower limit for human sensitivity under ideal conditions. What objects can we possibly feel below 20 mattresses? Widening our range of hard objects to place beneath, we find that the object has to have a diameter of at least 4 centimeters to generate the required 0.60 mm of displacement at the top. This corresponds to the size of a lime. To disrupt a night's sleep, we need an even larger object. After all, most likely the pea would not be under the fingertips but under the legs or back. Mechanoreceptors are distributed unevenly along the body, and studies have shown that our delicate fingertips are an order of magnitude more sensitive than our least sensitive parts. Our average sensitivity falls likely somewhere in between, corresponding approximately to a pineapple. So now you know. Next time someone claims to have a crown, the fair thing to do is to pull out a crown of your own.